Good morning. This is an update to the video about the air conditioning control system for the W126. And I thought I'm going to clarify a few things and I give you an update on where we are. I'm going to have this basically in three parts or in three segments in this video. The first thing is the important stuff. If you own a 420 or 5.6 liter version of the 126 or V126. V is for the long wheelbase, and I guess that's not really that relevant to this. But I'm pretty sure that you may have searched in your manuals, if you have the shop manuals. Usually the people who watch my videos, they are familiar with the Mercedes-Benz shop manuals, and they probably have purchased them online. And all of the 126 manuals basically show the 3.8 liter and 5.0 liter, the first version of the 126 until model year 85. And that is kind of confusing. And Mercedes-Benz added a addendum to the 126 when the second version was introduced, and I actually found this. That is a 50-page document, and it will update you. And when you read this, it will literally say in there, the automatic climate control with stepless blower is the same as for model 124. For function and test, refer to model year 1986, model 124, pages A15 to A39. And we got those models here. So I got this here, and this is basically the addendum for this as it was published, and you have now the locations of the parts for this in this addendum. And this is, I pulled it up, the actual section of the 124 where the testing is actually described, and you can go through this and you will see this is where all the test steps are. So if you want to troubleshoot the 126 second version, you have to get the manual for the air conditioning for the 124. And that is kind of confusing, but I got I extracted out the temperature sensors for the ohm readings, so I have the correct values we needed to perform the test on the new units for the 126 second generation. That is all in here. And there is something here, and this is important. When Mercedes-Benz does the model change, which is from August to September of that year, you have to look in your car. All the 5.6 liter versions, whether it's the Coupe, the SL, or the S, no matter what wheelbase that is, I believe that also applies to the 2.6 liter and to the 3 liter versions and the diesel versions. They changed the aux fan temperature sensor, which is mounted on the 126 on the intake manifold. And that is the sensor, which is usually blue. On the top there, it has a blue plastic piece with two pins, and they use two different values. Up to 87, that would have been the nominal resistance was very low at 20 degrees C, somewhere around 100 to 120 ohms. And then they changed it to somewhere between 5 to 8 kilo ohms after or beginning with any car manufactured 987. That is the number you will find in your B column driver side on that plaque. That will tell you this. So if your car is prior to 987, you're gonna have this type of sensor in there for coolant temperature. And that is important because if you get a new unit, they will not work with the old temperature sensor which is in your car. You would have to change this. This could be B13, this could be B11.7 or B10/8 on the 126s with the 5.6 and 4.2 liter engine. So you have to look in your wiring diagram to find the correct part, and you will have to change them out. This would be in case that you are actually changing the units, and that gets even more complicated. So this is just the sensors. All the sensors remain the same except for the water coolant temperature sensor. Then I have the update here from Mercedes-Benz on what they actually did at what point. And you can see this is for the air conditioning system 2. There's a air conditioning system 1, there's a 1B and a system 2. And you can see this in the dates, and this is all the early models. And then with the model change in 85, the first one was the control unit was improved. Then they changed the temperature sensor in terms of the improved quality control. This started in September 85. Again, 985 is the model change. And now it comes the system with test pulse, September 87. The units which were the early 126 or second generation do not have the test pulse outputs. That is important. And I looked then up in my DVD ROM. Until 887, they used 126 830.0585. That is the one without the test pulses, and that is also the one which needs the other temperature, coolant temperature sensor with a lower resistance. Then they made a change to 126 830 1085. That was valid until between 987 until 887, and then a 988, from 987 to 888, and then from 988 126 830 1085, 1185. That is the number you have beginning from model year. This would be then September of 88 until the end of the S-Class 126 in 92. And for the Canadians, that number was changed again here too in 87. That is beginning 987 until 887 until 988. These are the numbers for Canada. This is Canada only, 126 830 0885 and 126 830 0985. You have a different control unit in there. So from the introduction of the second generation until August of 87, Canada and the US have 0585 unit in there. And then it separates itself. Then the United States used for 1 year 1085, and the Canadians used 0885. And then it changed in September of 88 to 1185 and 985. That is something I wanted to show you. I verified the temperature sensors in here in my table book or the shop book. And I verified this, that they have the correct values, and then you can compare this 124, 126, 129 already, and the 201. And this is the book which was starting from January 89 on, so it covers all the previous. And let me just see what I got here. So this is kind of the important stuff. It also has the vacuum systems in here, and I wrote this in here, for my notes. I work quite a bit with these table books, and this is under chapter 83, and they also have the, again, clarified of what they had in there in terms of sensors. So this is a supplement here, this book, to the actual documentation you find in there. So you have to work really with all of the stuff. Now, this manual, this printout I got here is from the addendum I got on the DVD-ROM. This is the wiring diagram as I have it. And I couldn't tell you for what time because the wiring really didn't change. It was just the control units and that coolant temperature sensor. And this is the wiring diagram as it is in the electrical manual, which is supplied on the CDs, or which you can download for purchase on various different internet sites. This here is exactly the same as what you got here, this wiring diagram. So on the wiring itself, nothing has changed. And now the unit we have, so this is the first segment. This should just clarify this of what manuals to work with, where you have to find them. You will need the 124 manual to do a full diagnostic check on your air conditioning system, as they are completely identical with some differences. The 124 manual has probably, I would say, at a minimum, 10 to 14 different wiring diagrams in there for all the different versions of the 124. The wiring diagram you will find either in the addendum for Mercedes-Benz for the for the second generation, or the addendum, or the or in your electrical manual, either one of the two. And now the unit I have been working with, and what I showed you in the other video, is a real odd thing. I got this off eBay for $90, and it came out of a 87 560 SL, the R107. I believe it still was it already an R129? I think it was an R107. And you can see it is marked Mercedes-Benz, and you have the manufacturer, the MK, I'm not quite sure which company that is. MK made this, and it is a Mercedes-Benz part. But this unit does not have the part number on front. Usually when you take them out, the part number, these ones here, are usually embossed in here on the front, so you know which unit it is when you take it out of the holder. And that means that this was a pre-production unit, and this comes from the model change, and we will see this. Let me show you this. This is now the second segment of this video. I wanted to give you an update here. For one is, I have updated my wiring here, so I soldered the LEDs actually into the connectors. I've sourced the connectors. I can get them, and I can get the pins too, which means we can build a very cost-effective test unit for this. And I soldered my resistors in here, and the way I got this basically set up at the moment is that they're fixed, but I can, you know, just put something on here. And I got it set up for the temperature right now. Outside temperature, I think 10 degrees Celsius, and the interior 25 degrees Celsius, and so far and so on, because that gives us a base to work off. The test unit later on will be in a chassis similar to this here, a fairly large one. And what we're going to do is we're going to put the layout of the blower, you know, of the entire unit, the AC unit itself in the car, the climate control box, you know, where you have the heater core and everything in there, and we will mark the LEDs out here on the diagram. So we're going to have the diagram imposed on the overlay here, and the LEDs will be in the position, so you know exactly which flap is going to be activated. And then we're going to place potentiometers with a default setting, or, you know, with a mark on it, what is the normal range and where's a particular cutout, or, you know, the thing where you have to put it into the position to test it actually. And now back to this unit here, as we can see, let me move the resistors out of the way. This unit was manufactured, the black mark is out, in April of '87. And since it is unmarked, it doesn't have a part number yet. This was the future version which they were working on for the model year change, which came, this is basically a 1085. They used this until the end, and this was already in proper preparation for the change in 1988 September. So this is a unit which would be an 1185, and they put that as a test unit in there. And you can see the reason why this is a test unit is this here is not a microcontroller. And what they did on this is the base circuit board with the inputs and outputs, the drivers basically, and the input connection here for the sensors is exactly the same on all three units. The push button based circuit board. They didn't make any changes to this. What they did is they changed this here, and the actual versions with the pulsed output, diagnostic output, have actually a microcontroller on there. This part here is upside down right now. You cannot find, and the reason why is because this is an ASIC, an application specific integrated circuit. And what they did is they did the decoding of the switches here, of the push buttons and the fan control through logic. So there's no software in there. What they did is, excuse me, they basically gave this thing a clock which runs off a NA555 timer, or the equivalent of the, you can see this how slow the clock actually is. This clock, this whole system runs, the clock speed is 0.25 hertz. And the way they're doing this here is this is basically clocked through, and you can see you have different codes here, and they're putting this out depending on which push buttons you have switched. So these pulses will tell, is basically shifted through. Let me just see, I'm on a pin here. Yeah. Now if I were to push one of these buttons, the logic in there, the on-off states will change, and that will tell you then, or tells the unit, that's how they're basically regulating this. They didn't do this for software, but by actually using logic. That means NAND, NORs, ANDs, ORs, inverters. And you have the same thing here. These are latches, 1, 2, 3, 4 latches. 8-bit latches where you can latch a signal in, and they're basically bit banging this thing. So they're shifting bits through it to derive at a particular logic state, which then controls the whole unit. And this here is a analog relay, basically a semiconductor relay. And the reason why we had so many problems with the air conditioner unit with the compressor output was because the input pin of the water coolant temperature sensor, which is already the new version, the high ohm version, goes through pin 3 and pin 4. Let me just see. And you can see this on how this is switching. It queries the sensor 3 times per second. And that, depending on how the signal is, the changes in terms of amplitude. And this is the actual output, or the in-out, which goes to the sensor. And you can see is that the control input is on both channels. And you can see this, that's just a needle impulse. And you can see this, that is that here on the output side. So if I put my tester here on the actual pin, it's gone. And you can see that the signal is actually distorted here. We have 2 things here. Let me see if we can speed this up a little bit, then we should be able to see this better. I just wanted to show you this. So this was already defective. The second impulse input, or the pulse, the second pulse after the big one, is incorrect because that is a malfunction of the device. I have a new one coming. On the later version, which went into full production, this ASIC was replaced with a microcontroller. And the way you can tell this if you have an ASIC or a microcontroller in your unit is by having a quartz, a crystal quartz. That is the Do I have any quartz here? I don't think I have any. I usually don't work with them. They're usually rectangular in a metal can, have 2 pins on it, you know, and that's how you can tell the difference. Usually they have then a different part. I believe they use the Motorola HC68 type microcontrollers back then for this. But this is a full-blown digital design, and that was done to see on how they're gonna write the software, and they tested this out. So this is our clock. This is a regular op-amp, 2-channel op-amp. Then you have 4 latches, 2 resistor networks, and some discrete transistors to switch things and turn them off, and fairly large-sized capacitors to do the ramping in this. These are basically the time controls on how fast the the intervals change for the fan control when it goes high and low, and that sort of stuff. So this unit here, this circuit board, could be replaced by a regular circuit board, production circuit board. And again, on these circuit boards here, when you get this white color and you look at them from the side, this is pretty nice. And I resorted this board too, because those are the boards which will soak up with water, with moisture, with humidity. These circuit boards here, you can see the difference. This is FR4, this is fiberglass, but those ones you won't have any problem. You can see the different colors. As soon as you got this brownish in there, this is basically Perdinox based circuit board material. All of these boards are going to have to be resorted at one time or another, because the moisture get in there and the solder joints are going to deteriorate. So that completes this here, so you get an idea of what we're going to do. I think the cost in this, if I get the for the test unit, if I get the pins, which are silver plated from Mercedes-Benz, then the 2 connectors itself will cost me $57 just in cost. So I'm trying to source them in just a regular nickel cadmium plating, which should be a fraction of the cost. And then with the chassis and the parts we will need, you're probably looking at $125 to $150 retail, and this way you can test these units out. The counterpart to this, where we would plug into these connectors for your AC system in the car, will look like this here. We'll have a graphics display, a vacuum pump, and you basically have a vacuum output which will connect instead of your on the distributor on the vacuum switch itself on that 7-pin thing. And this way we can test each element out. That test will take about 2 hours to complete, and we will measure the vacuum, if it is holding the vacuum, and if the vacuum holding is within the factory specifications. This way you can get a clear picture of it. Plus we will check the amp current for the pump and the current for the monovalve, so you know that the pump and the monovalve are within specs. And then we will check all of the temperature sensors. So this unit will then ask you whether or not to start the car. And then when you start the car, we will be able to actually simulate everything. We can turn the compressor on and off, check the temperature drop in the evaporator temperature sensor to see if it goes down. Then we can tell you whether that's working. We can tell you if your fan is going to work right, the auxiliary fan, and then we can start the water pump up and the monovalve open and close it, and do a check with the temperature sensor in the heat core, and we can regulate the speed control and change the valves. Basically, we're going to do this, what this unit does, but as a test unit, and that is going to be similar, and it's going to be an automatic test, which means you're going to get a rundown of this, and you will know exactly what every part in your system is doing or not doing, and which part should be replaced. The cost on this unit to do a full test is going to be around $300 or $400, but this is going to be something else. And you will be able to use this on a 124, on a 201, on a 129, and to a certain extent on the 140s as well, with some modification to the software. So that is in the plan. This is going to come. And then the other thing is we're going to incorporate a 2x20 line LC display with a backlight into this unit here, and this will be the advanced tester, so you will be able to select your vehicle, what you have, and you hook this up to your diagnostic socket, and it will have the 4mm and the 2.5mm plugs, or 2mm for both sockets. And then you can also hook up the TD signal to this. It will show you the RPM, and you will be able to put in hook up the duty cycle. So we can actually read the ongoing error messages from the ECU while the car is running in warm up. And once it switches over from warm up to closed loop, we will indicate exactly of what the duty cycle is, so you can easier adjust this, because this will measure the duty cycle exactly like the Bosch did, so you don't get this backwards. The reason for this is, let me show you this. We can do this on this here. This is the Huntech oscilloscope I was talking about. I think I paid $200 or $300 for it. And this one here can be set up pretty neatly. Let me go out and go to measure. And you can see here we have two, let me zoom in. We have two duty cycle, a negative duty cycle and a positive duty cycle. And if I go on to our test here, let me go on here, it should read, and you can see where the duty cycles are. So you're 98% at the minus, and you're 1.26 on the positive. And the digital meters out there, they have one disadvantage. They're either displaying the off cycle, which is called the minus duty cycle, or they're displaying the plus duty cycle. And that depends, so you have to check this. The Bosch duty cycle tester measures the minus duty cycle. So this would indicate 98%. Most of the handheld digital meters will show you the plus duty cycle, and you cannot switch them. That's why that is better to be done, unless you know what you're doing, with a oscilloscope like this here, where it clearly indicates this. So on the handheld unit, you would read 1.26% on the display, and on the Bosch unit with the analog indicator, you would read a 98.7, or it would show you basically 100% since it is an analog instrument. And this is what we're going to do. So you will have the unit here with a 98% indication of your duty cycle. This way you can get your mixture set up correctly. This is going to be critical for all those people which have to meet emissions control or SMARC standards when they have to go in for the testing. This will give you a correct reading, and you will be able to measure this. So you're going to do the, and we're going to, of course, indicate not just the numbers of errors. So when it blinks 9 times, it will tell you 9, because you can select your car or your engine. You will be able to see the 9 equals sensor, and then if you have multiple in there, we're going to have a next button and the yes and no button, and you know, a more of a menu, so you can then go to the next one and the next one and the next one, and then you have a reset button where it automatically resets either all error codes you have out of that module or only one. This is just a short rundown. This was the last segment of it, and with that, you have a great day.